So, hello everyone. My name is Paolo Sottovia. I'm a software engineer at data platform at Canonical, and today I would like to present you our Charmed Spark solution that we released like a few days ago. So, first of all, what is Spark? So, Apache Spark is a data processing framework that is meant to work with large data set and process them, and it can be used to process that for many tasks like data science task and machine learning. During the past years, it grows a lot of attraction, and it overcome Hadoop already in 2016 as a big data processing tool, and now basically is the leader in the market for big data processing. Why is this? Why this happened? Because it is a really nice framework with nice capabilities and really efficient, and it has a lot of integration with many applications such SQL databases, uh, Kafka, Redis, Elasticsearch, and many others. But how Spark works? So this is a simplified diagram that shows how Spark works. So we have a driver program that contains the logic, and this driver program talks with the cluster manager that coordinates resources executors that really process the data and do the task and do the assigned task, and then give back the results to the driver program. Apache Spark has many modules. It means that it has like standard APIs to work with dataset. They have a nice abstraction called RDD that in which you can apply modification and process your data. You have Spark SQL to interact with SQL or data frames language similar to Pandas. They have modules for machine learning, similar to what is done in scikit-learn, for example. And they have other modules for processing large graphs, and also for processing streaming data. The cluster manager in Spark can be Spark can work with multiple cluster managers. The first option is to go for standalone, so you deploy your Spark applications on your Spark nodes on bare metal machine, or for example, it was possible in the past to use Apache Mesos, or you can deploy it on an existing Hadoop cluster, or since 2018, you can do that on Kubernetes. And this is the way in which Charmed Spark works. In that way, we can provide the same UX, scalability, and many features on multiple Kubernetes Kubernetes like microcase, Charmed Kubernetes, AWS AKS, or Google Cloud, for example. And why we came up with Charmed Spark? Because configuring your cluster for working for submitting job with Kubernetes is not so easy. There is quite a high learning curve, and what we aim is to provide a seamless and easy way to use Spark on Kubernetes, and this is done with three main components. The first one is a rock image in which we pack all the binary of Spark and other services. The second one is what we call Spark Client Snap, that is a snap that contains all the logic to configure and interact with your cluster. And last but not least, we also provide a set of services through Charm and Juju. But how this, let's say, works in reality? So our user can interact with the snap, and the snap is responsible for creating service account, and all the configuration needed for the cluster to be able to run Spark jobs and to submit Spark compliant application to the cluster. And to configure also, for example, to configure all possible configuration options to set up, for example, storage and other options. Then with Juju, we expose many other services, for example, monitoring that can be, let's say, used by the user to monitor the usage of the cluster, how the applications are performing. So now I would like to bring you in how this really works. And I prepared a quick demo in which we will go through 3 steps. In the first one, we will quickly set up a cluster to work with Charmed Spark. Then I will show you how to different ways in which a developer can use that to submit jobs and to work with Spark. And in the last steps, I will show you how you can monitor the execution of your application in the context of Charmed Spark. Everything is run on microcates, and let's start from the setup phase. So in the setup phase, what we want to do is to configure with the snap. We want to configure the service account and the roles that Spark needs to run on the cluster. And we want to provide configuration option for our Spark jobs to, for example, to access the storage. So here I have microcates already installed due to time constraint, and some add-ons are enabled. So we have DNS, min.io, role back access control, and storage enabled for this demo. With a simple bash scripts, I check that the S3 endpoint is reachable and get access key and secret key. And with a simple command, you can also get what is the web UI IP for your S3 endpoint. Then I set up a set of environmental variable that will be used then to run the different programs. And here I prepared like a script that simply pushed to S3, to our S3 hosted in min.io, some data and the script that we will use during the demo. So this can take a couple of seconds. Here is the configuration that we pushed for X3, for example, and that we will apply with the client snap. This contains the driver that we will use for communicating with S3 and the credentials. Now we can create the namespace for the demo, and after this we can use our snap and set up the service account with the configuration that contains the S3 the parameters for S3, for example. And also with the snap, we can check that these parameters are configured correctly. Now I will show you that in the bucket that we created, there is like there are 3 folders. One that contains the data, a small CSV, one that contains the Python script that are run with Spark, and the third one is just a directory that will later be used to contain the logs of the application. But now it's time to see how we can interact with Charmed Spark, and here we still need to use the snap, and we can, let's say, interact with Spark and with the cluster. So we propose many ways in which a developer can use our Charmed Spark. The first option is to run it with a Docker image simply and open a Jupyter lab that is already configured to use the Kubernetes cluster. The second one is to directly submit a Spark job, or for example, use a Spark shell, or a third way, or an extra task in which we can see how we can use Spark with other application, for example. So for the notebook, we just need to run Docker and basically mount the kubeconfig, your local kubeconfig inside the image, and with the help of Pebble, we can run a service that enables our Jupyter notebook. Here is the notebook. It is as I said before, the Spark context is already injected into the notebook. So here we already have Spark, and basically what we are doing here is check that the Spark context is correct, set up a bucket, and then we read the data that in S3 that I showed you before. This takes a little bit of time, few seconds, because under the hood we have like the pod that are spinning up with like the executor that are allocated for this notebook. So the driver, in this case, the driver program is the notebook itself, but the executor are hosted in microcrates. So this like now is the job started. It will take a little bit because I recorded the video with this internet connection, so the images are a little bit slow to download. But you will see that in a second. We read the data set. We can, for example, print the schema of the data set. We can show a little bit a preview of the data, and now we can start to analyze the data. And here we can also do some queries and some small analytics on the data. And as you can see, we can simply sort the data and transform them to pandas. As you can see, these are represented as normal pandas data set. And for example, in a command, we can print the data, inspect the data, and so on. Yeah, this is the first way in which you can interact with Charmed Spark. Pretty easy, pretty useful for the data science that want to, for example, use it on a notebook. The second way is to use Spark Submit. That is a native command of Spark, and here we are using the snap. We create the Spark Submit command, and you just need to, for example, in this case, specify which script you want to run, the input data and the output data, and where you want to write the output. For example, this is the input and the output are defined in the Python script. Here you can see the job is starting. We have our driver pod running. In a few seconds, the driver pod will spawn the executor pods that will in reality do the job and process the data and do and execute the logic that we have in the Python script. Here we have now the two executors, and in a couple of seconds, once the job is done, they will finish, return the result to the driver, and the process will stop. So now the execution is completed, and we can check if we have the result in S3. So we have now a file, no, a folder first with two files. The first one is metadata files that tell you which if the status of the job, so it's succeeded, and the result of your computation. So here you can we can inspect the data and see that we sorted the data as we wanted in the script. Then there is also the possibility to access Spark with an interactive shell. In this case, we are still using the snap. We run the command Spark shell with the username and the namespace that we created in the setup. This will in this case, this will just spawn two executors because in this case with the shell, the driver of the program is the shell itself, and we just have like two executors that process the job. So here we just do a minimal program that computes like pi, and as you can see, the computation is running pretty fast, and it is running in the two executor hosted in microcades. Once the executor are still alive until we close the section with the shell. Yeah, the last things that I would like to show you in this case is how we can, for example, use Charmed Spark with Kafka. In this case, we are using Kafka Kates, Charm developed Kafka and Zookeeper Kates, charms developed by the data platform team. So first of all, we deploy Kafka and Zookeeper, and we deploy a third charm called Data Integrator that is able to relate with Kafka and give us the credential to access the Kafka itself. So here I speed up a little bit the deployment of the different charms, and after let's say in reality it's a minute or two, and after this we can relate the data integrator with Kafka to retrieve like the credential. This will take like 30 seconds in reality, because when Kafka need to reboot to open like the listeners. Here we have like the username and the password retrieved from an action of the data integrator. And what we are doing now is just to deploy a testing apps that is simply generating a lot of messages to Kafka, and these messages then will be read by Spark itself and processed. So here we just submit, let's say, another application. In this case, we need to specify a couple of more packages because we need to use like some tools, some libraries for accessing Kafka. And here we have like a lot of messages flowing, but what I would like to show you here is that at a certain point we will see a batch of here computed and another batch of data computed here, which the count of with the count of all the messages retrieved so far. So for the last bit, I would like to show you two ways in which we can monitor a Charmed Spark application. And here we are making use of Juju and charms to do that. And the first option we have is to use the Spark History Server, a component integrated into Spark itself. And for this we've wrote a charm that that is called Spark History Server Case, and yeah, this first of all we deploy this charm and the S3 integrator, that is a charm that can handle S3 credential and share them with applications. And here we just set up the S3 credential into the S3 integrator, and now we have like everything up and running to run, let's say, our application. The only thing we need to do is to add an extra configuration with the Spark client snap to enable the logs to be saved in the directory we specified. Sorry for the quality of the video. It's really bad. And yeah, now the application is running. It's a simple example that computes the pi value like the one before. And here in the Spark in the S3 we have like a file that contains all the logs of the application. But the nice thing is that with the Spark History Server charm, we also have an entry point in which we can see like the jobs. We can download the logs, and for each application we have an entry in this table. And here we can see, for example, the history of the execution. So when the application started, when the executor started, the jobs that the executor were running at that point in time. The last things that we can do is to integrate Charmed Spark with COS, so Canonical Observability Stack. And here, first of all, we need to deploy COS. It's a bundle, so it's a set of charms with a relation already pre-configured. So with one command you can deploy it. And this phase is really speed up. In reality, it takes like 10 minutes to deploy all of it, but it's a set of application like Grafana, Prometheus, Traffic that will basically help you to have like dashboard, scrape logs, and I mean all the application that you need to have a complete monitoring framework. And after everything is deployed, we add a couple of more charms. Here we had like the Prometheus push getaway, and we also add the COS configuration case charm to configure the dashboard that we want to show in Grafana. We need to add this to charm because we use like instead of pulling metrics from Kafka, we are pushing them from the different pods directly into Prometheus. Here we just run an action to Grafana to get like the passwords, and then we export like the endpoint for the Prometheus push getaway. And now we just need to run our application, and with some, let's say, configuration applied by the snap. so after the application is complete, we can log in into, or while the application is running, we can log in into Grafana, and this will in Grafana we will have like to go to the dashboards, and to a Spark dashboard will show up, and this dashboard contains like all the metrics that were collected from the pods. Here you can see that there are multiple metrics shown, and here on you can, let's say, specify which job you want to monitor, for example, and yeah, and at the end, if you have multiple jobs, you can just select the one that you want on the top, at the top menu. So last but not least, today I just show you how to quickly start working with Charmed Spark. But tomorrow, on November 6th, we have like another presentation at the Operator Day, in which my colleague Enrico will present how to work with Charmed Spark and to scale it to production in AWS with EKS. So thank you. If you have any question, I'm here to answer.
I have one for you.
Yes.
And I'm holding the microphone already. In
Sure.
one of your very early slides, in one of your very early slides, you showed the cross between Hadoop and Spark, Hadoop going down, Spark going up. But there was a key moment, it looked like in like July of 2022, where Spark just really took off. What happened in the ecosystem then?
It's a kind of every year there is like a benchmark done by for this framework, and if I remember correctly, in that year Spark really overcome Hadoop in performance like 10x.
Okay.
And basically there was like a huge set of people that were like interested in that because it was like a big result with respect to the previous year. So no one expected that, and this probably was the cause for this peak in that period.
Okay, thanks.
Hey, so one thing I did see was like kind of in your presentation here, you had like recorded a lot of videos. I was just kind of curious, like how long did it take you to like really go through that whole example?
I would say a little bit of time.
I noticed it was yesterday.
No, I did it also 2 days ago. But yeah, I mean, it takes a little bit of time, not much to be honest, because I used like an automatic tool to do that. So all the commands are not, let's say, typed. They are executed, and you can, let's say, just run a bash script and everything, and you just need to record the screen. But yeah, it can take like, for example, for the observability one, it's like 30-40 minutes of recording that you need to cut, adapt, because I mean, also the connection here at the hotel is not the greatest, so it takes a little bit of time. And of course, I was running on my local machine, so.
Just a couple of hours if you know what you're doing.
Okay. And then I just have.
Oh, yeah.
And then what tool did you use to like handle the typing? Because I could definitely use that.
It's a tool discovered by one of our manager, Alex Lutai, and it's called Demo Magic.
Okay, thank you.
I have one question regarding testing. So for Juju in general and for Charm. So I was wondering, since you are wrapping like application that have their own logic with their own functions. How do you decide what to test and which integration to test? So, for example, you show Kafka and Spark. So, what do you usually decide to test?
So we would like to test all possible application in principle, but first of all, we started with the ones that we have in our let's say in our data platform teams, and Kafka was one of them. I can tell you that in the next months we will also work with SQL database like Postgres and MySQL. So it's just depend on also on the looking at what is really of interest for the community. So if there is like an application that is really requested, we can work on it.